Here's example 4 on page 365, and with all the stuff we've done, I think I get the idea of what these things look like. Now this is the growth, this is a bear problem, the growth rate of a population of bears in a newly established wildlife preserve is modeled by the differential equation. The rate of change of the population with respect to time, dp dt equals 0.008 p times 100 minus p, where t is measured in years. Now, if we look at our general form, this obviously is the p, this is the k, this is the m, and again p. So you can see where we have the standard forms, and just have to interpret that. Now, we always want to get it into this form, something times p times the carrying capacity minus p, or what something minus p. And sometimes you have to shift these around and to get in this form so you really know what you've got. So keep that in mind. So what we want to do is letter A. Letter A, they're asking, what is the carrying capacity for the bears in the wildlife preserve? Well, carrying capacity is M, so once we identify this, it's just 100. So the carrying capacity equals 100. That means when I start getting close to 100 bears, things start slowing down because I don't have enough food or habitat or resources to support more than 100 bears. That's it. If I put 100 bears on the island, I wouldn't get any more. All right, there wouldn't be enough, so some might just not have enough to eat and starve, and we'll go down a little bit, up a little bit. It's not going up, but it's not going to pass 100. So a few may have to die off before it starts to build up. Okay. Nature's tough, I guess. Okay, so you got to be aware of that. Okay, what is the bear population when the population is growing the fastest? So we did this on the exploration, and it's growing fastest when it's half the carrying capacity. Remember, if we go back and we look at our graph, what we did we came up with this 1/2 m in exploration number 2. Say this is our growth rate, and it's growing the fastest when the slope is the steepest or most positive. So it's growing fastest right about here, and that happened to be half of m, halfway up here. So I know that when I'm at 1/2 m, when my population, when p is 1/2 m, that's when it's growing the fastest. So p equals 1/2 m, that's growing the fastest. Well, that's going to be 1/2 of what? 100. So that's going to equal 50. So when I have 50 bears, p equals 50. Growing the fastest. Okay? And letter C. What is the rate of change of the population when it's growing the fastest? So we've got our formula. And that's what we started with up here. Fix this here. I got a card underneath there, no wonder. Okay. So we just substitute 50 for p, because that's when it's growing the fastest. And then we're going to find our rate. So that's real easy. Times, and p is going to be 50. times 100 minus 50. And that's going to equal 0.008 times 50, and 100 minus 50 is 50. Okay, then you can multiply that out with your calculator. You can work it out also on the side. 5 times 5 is 25 with a couple zeros, and times 0.008. So 8 times 0 is 0, 8 times 0 is 0, 8 times 5 is 40. Carrier 4 is 16, 17, 18, 19, 20. And how many places is the right decimal? 1, 2, 3. 1, 2, 3. So 20. So what is the rate of the change of the population when it's growing the fastest? And that's measured in years. Time is measured in years, so that would be equals 20 bears per year. So when I have 50 bears, okay, my population is growing at a rate of 20 bears per year. Just at that moment. It'll slow down as I get closer and closer to the carrying capacity. Okay? So again, that's the rate of change of the population when it's growing the fastest will be 20 bears per year. Okay? And up here, to get my units right, the carrying capacity is 100 bears. And it's growing the fastest when I have 50 bears. Oh, right, I have this. Okay. All right, so that, lots of times we see problems like that on in the multiple choice of the AP exam. But sometimes they disguise this, so you have to look at this. Now take a look at example 5. I won't have time to go through that right now. There's some tricky stuff with the signs when you're taking the integrals because you have a negative, so you have to do kind of doctor up the du with a negative sign. But I kind of explain those when I work out problems number 29 and 31. I think 27, 29. Okay, so we do 27, 29. I kind of explain what you do with those sign changes. And don't worry about using the graphing utility to do a slope field because I never gave you that program, but so we don't really need to do that. So just solve the equation for P of t.